Full screen. Okay, so I'm really glad that you all are here. Welcome to the kickoff of the first annual Odyssey DevCon. So this is about an open source project, and we've been working on our open source community, and so we want to try to help people get started with working on the code base. You might not understand the layout of the code or the technologies or the team behind the project or the process that we use to get things done and communicate. So that's kind of why we have this developers conference, and we're also kind of leading up to a hackathon in the Odyssey Symposium. So some of the things that we're going to talk about today are just the different the HADES project and all the different packages underneath it, as well as kind of get a deeper look at a few of them. I'm going to talk about how to get started with the code base and get started with these packages, and documentation, contribution guidelines, testing, and release processes. But this is really a long-term journey, so I'm just kind of giving an overview today, and it's kind of a long-term thing to really get into these packages. So HADES is a set of R packages, although I don't think it's restricted to R. It's for performing large-scale analytics, population characterization, causal effect estimation, and patient level prediction. We want to go kind of directly from from data to our estimates, figures, and tables, and have this be kind of like an automated pipeline, and in Odyssey fashion, like really have standardized analytic tools that we can use. So we interact directly with the CDM. And it kind of fits in between the Atlas tool, which are Anthony Sena is talking about in the other track, and the network execution and evidence dissemination. So we have this sort of approach to generating evidence in Odyssey. The place really to get started with HADES is, I think, this fantastic webpage. Odyssey.github.io, and we have a developers tab here, which has a lot of information for developers: contribution guidelines, release processes, HADES roadmap, and this webpage also kind of describes how to set up your environment, get Java installed, R installed, and all of that. So this is a great webpage to check out. I'll actually think it's worth showing on here. So here this page here has all the different packages, and we have a set of supporting packages, some packages for evidence quality, patient level prediction, which Jenna will be talking about, and population level estimation. There's many different languages kind of going on in HADES. Even though we're using R packages, we have a lot of C++ code and a lot of Java code and some Python code going on. So there's areas to contribute if you are a Python developer, or if you're interested in Java or C++, or even CUDA if you are interested in GPU computation. There's places to work on these different languages inside HADES. HADES has been growing quite a bit over a number of years. So one thing that we've been doing in open source community is looking at some of the data from GitHub, and you can see that the number of different authors has been increasing, and the number of repositories that we have has been increasing. And this includes kind of the skeleton packages as well as the main HADES packages. And so we're interested in kind of bringing in new developers, people who want to contribute either just in their volunteer time or as part of their job as maintainers of the software tools. This page here, which we can look at on the developers website, package statuses. This is a nice dashboard that shows all the different packages in HADES, as well as the maintainer, importantly, code coverage, build statuses, so is the code currently passing, all of its checks, and versions. We meet once a month in Odyssey Teams to talk about HADES, coordinate between developers, decide on common best practices, and kind of align on a high-level roadmap and drive progress. So I'm going to kind of walk through and looking at the anatomy of a HADES package, and I'm going to try to stay. I'm going to look at database connector because I've been looking at that myself, but I'm going to try to stay general and talk about how you would kind of get involved and look at. You could take any one of the HADES packages and kind of apply the same process. So the first step is to fork the package. So this is sort of your initial starting point, and we can look at let's find database connector here, and this is some nice documentation, but we also have a link to the source code. Click on browse source code. It takes us to the Odyssey GitHub repository, and then we click this fork button up here, and since I already have a fork of it, I'll go there. And so now I have this essentially copy of the code, which I can work on my own personal GitHub account. So you definitely need a GitHub account, and I can make changes and then create a pull request, which is a way for me to have the maintainer of the package look at the changes I've made and integrate them into the code base. So this fetch upstream button is nice. You can do this in Git as well, but this is a way that you pull the changes in the Odyssey database connector into your fork. So right now everything is up to date. But if it wasn't, I could just click fetch and merge and keep my fork up to date. The next step is to clone this onto your local computer. So you can do this with the terminal or the command prompt on Windows, or you can just start a new project in RStudio and put in this GitHub URL, and we'll download all the files, and now we have our all our files in RStudio. There are multiple branches that are used in HADES, and the two main ones to be aware of are the main branch and the develop branch. So we recently switched over from master to main as our default branch, but you can see we have a main branch, and there's some various issue branches, but the primary two that we need to pay attention to are main and develop. So if you're working locally, you can create an issue branch or whatever branches that you like, but when you make a pull request onto the actual Odyssey package, we'll use the develop branch. Main is always going to be up to date with the latest release version. So anytime all the code in main is really our production version of the package in current release. So people will have different levels of familiarity with R and R packages, and so we won't go through a ton of that here. It takes a while to kind of get up to speed with it, but I want to just orient you to a few things to look for in the R package. So the R folder is kind of the main folder with the R code. When we're working on when you load an R package, it will execute all of this code and create all of the objects and functions that are in these files. So when you're getting started with working on a package, you kind of want to browse this and get an understanding of what these files are. Oftentimes, or I think pretty much always, there'll be a file with the same name as the package. And this is where we'll have some documentation about the package itself. Maybe some helper functions, but also if the package includes embedded Java code, you'll see this onload function that will start the JVM. So like I was mentioning, a lot of times there's different types of embedded code in these R packages. In this case, we have Java, and that is the case for several other of the HADES R packages. So kind of browsing this code, getting a sense of what's there, is a good place to start. Next, we have a folder called inst, and this is a folder that contains files that you want to access, kind of like static files that get installed along with the package. And so we have a Java folder, CSV, and SQL. So a lot of times there might be embedded SQL code in some of these packages. So that will be there. In the Java folder inside inst, we have our jar file. So in this case, here we have this database connector jar file. And I'll talk about kind of how that gets there and what that is. We might have some CSV files, and we have this doc file. These files are accessible from R using the system.file command. So I don't think I have a slide for that, but the system.file. This is how we access these files. One thing I use a lot in RStudio is this find in files function. So this is a global string search function for the whole package. So I can just type system.file and see where these files are getting used. So here we're reading in the CSV that's inside the CSV folder. Next, we have a Java folder here. So this is where the Java code lives. And in this case, so some of the packages have Java code, some of them don't, and some of them are actually heavy on the Java side, some of them are lighter. In Database Connector, all of the actual low-level connection to the database is handled with JDBC, and so the Java classes are really important. So we can open these up and take a look. And so here we have like an authentication class that has one method, and we can again use this find in files function to kind of see where is this called and where is this used in the package. So down here I can see, okay, well, it's used in one place, and so it's in this connect file. There's a set path to DLL function in R, and so this is how we're calling that one method for that one class, that authentication class in Java. There are we have, if we're using Java in the package, we have to initialize the JVM using this JPackage function call. Here we looked at this how a Java function kind of gets imported into the R and gets wrapped into an R function. Similar type of thing will happen with C++ code, and in Python we're kind of using the reticulate package to do that. We can see different ways in which we're creating the Java object in R. So here we use this .jnew function to create the Java class, to initialize the Java class, which is a batched query, and then we can call methods on the batch query using the jcall function in R Java. So one thing is like the double colon operator is really important, and this tells you the package name, double colon, and then the function name in that package. So here we're using jcall, we're passing in the new database connector batch query connection and calling the clear method. So you can take a look at, this is in the batch query object, and we have a clear method here that's getting called. So several of the HADES packages have Java code. Here are, I think, all of them, but maybe there's more I'm missing. I'm thinking big K and N should probably be on here also. And how the jar files kind of get passed between kind of the Java projects and the HADES R packages is well, it's just good to be aware that looking at overall this whole ecosystem, we're passing jar files around. So in some of the HADES R packages, like SQL Render, all the Java code is kind of embedded in SQL Render, and there's a SQL Render.jar file that gets created, and that gets put on a repository and is embedded into WebAPI. So there's this dependency that WebAPI has on SQL Render. Similarly, there's some of the HADES packages include jar files where the Java code is actually in a different project, is in at one of the Java projects, and Circe R is one of those, as an example, where you'll see a lot of jar files that are coming from the Circe B package. So I think there's a lot of kind of cross talk between the Java and the R space in HADES and in how it fits into the larger Odyssey ecosystem. And as I was saying, we have in different other types of embedded code, C++. We have in Cyclops, self-controlled case series, cohort method, empirical calibration, and then we have Python code, which is added via the reticulate package, mostly in the deep learning patient level prediction, but also the patient level prediction package uses reticulate. I want to talk a little bit about interfaces and unit testing. This is a really important topic. So each package you can think of as having an interface, and these are just all the function definitions. Each and all the interfaces all have really good documentation on the HADES website. So if we go to packages, say database connector, reference, this is the documentation for the package interface. So we can see each function, the possible things that can be passed into it, and description of all the arguments, as well as under value, this is what the function returns or the side effect that the function has. So what we want to make sure that is very well documented is what's the expected input, what's the promised output or side effect, and generally what the function does. And in R, it's pretty much all function calls. And then we have a set of unit tests. So these are in the tests folder. And these unit tests are really to protect the interface definition. So these, the goal of the unit tests are to test the interfaces, make sure they work and they continue working. And we're constantly kind of making sure that we have good code coverage, meaning that all of the functions are tested, all the code is tested. But that way we know if we can separate the interface versus the implementation. We can change the implementation, and if all the tests continue to pass, then we know that we're safe. So some of the unit tests, like in the database connector package, require certain environment variables, because with database connector, we have to test that we can connect and use a variety of database management systems. That's not the case for all of them. To run tests locally, we can use the build tab, and there's a keyboard shortcut to test the package. So this will just run all of the unit tests. We can look at code coverage using the covar report function, and this gives us a high-level overview of where we have good coverage, where we need to work on adding more coverage. And then there's also this thing called R command check, which is a broader set of checks that check to make sure that the R package kind of has all of the standard things, and it includes running unit tests. And R command check is automatically executed whenever you push a change to GitHub using the GitHub Actions framework, I guess. So that behavior is controlled in a file called rcommandcheck_hades.yaml. It's a YAML file, and there's documentation on GitHub's website about the structure of this file. But this is where we're able to set up our continuous integration. So anytime that we make a push to any branch or a pull request, these tests are automatically executed, and we can make sure that they're continuing to pass. So here we can see for the database connector package, there's an actions tab on GitHub, and we can see all the various tests that were executed. One note just about versioning and releasing. So each of these packages have R versions. There isn't a overall HADES version. We just release each R package kind of as needed, and each package kind of has its own cadence depending on the maintainer and the needs. At any given point in time, we should have a completely functioning set of packages, and we can use RENV to kind of capture that environment and use a particular set of HADES packages. There's no guarantee that a package in at one point in time will work with a different version at a previous point in time, but at any given point in time, all of them should be working together. So so whatever time you're working on a study, the current version of all the packages should work just fine. I'm going to just wrap up real quickly because the time went by pretty quick. It's already 8:30. The workflow basically is that you fork, you create you create your commits, you push to GitHub, and like it's very possible that you have a test failure, so you might have to tweak that. And then once you get all your test patch thing, you can create a pull request, and that can be merged into the Odyssey develop branch by the maintainer. And then it gets merged into the main branch on the next release. There's in general a really important development loop to kind of get under your fingers, I guess, which is just this: build the package, run tests, edit source code, and the tighter this loop is, the faster you can work on the code. So in the open source community, we're very much oriented towards supporting new developers and helping people get started. A couple resources to check out are 2 books which are freely available online. You can just Google for them and find them easily. One is R Packages, and the other is Advanced R. And these books are really helpful in sort of getting the lay of the land.